Welcome to the UpNext AI podcast. It's Tuesday, July 14th, 2026, and here's what matters in AI today. Our top story comes from Wired, which reports that researchers at the Technical University of Denmark used generative AI together with a quantum computer from Orca Computing to generate novel peptides, short chains of amino acids that can bind to specific proteins in the body. That matters because peptide binding is a key step in areas like vaccine development. According to the report, the team ran its generative model in a hybrid setup linking quantum hardware with traditional processors, then tested generated peptides in the lab. Wired says the model produced more successful peptides than its classical counterpart, with the strongest gains showing up where training data was scarce. That last point is probably the most important one. The researchers say they are especially interested in drug development for underserved populations and rare diseases where data gaps can be a real constraint. The story says the effort drew on $28 million in funding and frames the project as an early proof that quantum computing could aid drug discovery rather than just serve as a futuristic talking point. There are still important limits here. This is research, not a deployable product. The Wired report also notes that current quantum systems are still too small to run full-scale cutting-edge AI models, and that finding a peptide that binds to a target is only one step in building an actual drug or vaccine. So this is not a claim that quantum has suddenly solved pharma, but it is a concrete example of a hybrid workflow producing a better result in a real biological task, especially in lower data settings. And if that continues to hold up, it could matter for personalized immunotherapies, vaccines, and neglected disease research where every efficiency gain counts. From there, let's move from lab science to the structure of the AI market. Nathan Lambert at Interconnects argues that open models have, in his words, about 6 months to live in their current form, and he describes this as the most serious test yet of open-source AI's viability. This is best understood as a perspective piece, not a reported government announcement, but it captures a real anxiety in the ecosystem. Lambert's argument is that policy pressure is building around frontier capability open-weight models, especially as more capable models approach the performance range of top closed systems. He also argues that once governments create review or restriction mechanisms for open models, those rules may move more slowly and more harshly for open systems than for closed ones. The practical reason this matters is simple. Open models are not a sideshow. They underpin an ecosystem of inference providers, fine-tuning companies, and products that depend on continued improvements in open-weight releases. Lambert's piece also ties the debate to two broader pressure points he sees unfolding at once: distillation concerns and emerging policy around frontier capabilities. His warning is not that open models disappear overnight. It's that the next phase of regulation could make their development and release much harder, especially if policy treats open distribution as uniquely risky. Again, that is his thesis, not a settled fact. But it's a useful marker for where the practitioner conversation is heading. The bottom line is that the next 6 months could tell us a lot about whether open models remain a durable alternative in AI or become a narrower, more constrained lane. For the research section, a practical benchmark paper called MM-ToolSandBox is worth your time. The paper, published July 13th, introduces what the authors describe as a unified evaluation framework for visually grounded tool calling agents. In plain English, this is a test for AI systems that do more than chat. They have to look at visual inputs, understand changing software states, and make the right tool calls inside a realistic workflow. What makes the setup notable is scale and realism. The framework includes a stateful execution environment spanning more than 500 tools across 16 application domains. It supports multi-image, multi-turn tasks, including messy but realistic behavior like goal changes, corrections, and state mutations, and the results are a useful reality check. The paper says that across 12 state-of-the-art models, even the best ones scored below a 50% success rate. The authors also say 53% of failures came from incorrect information extraction from images, even when the broader task workflow was otherwise right. That suggests a specific bottleneck. For smaller models, the problem is often deciding what to do. For larger ones, the problem shifts toward visual precision, basically misreading what's on the screen. Bottom line, tool-using agents may look impressive in demos, but dependable software operation is still a long way from solved. Are you building apps with voice? Elevate your app's voice capabilities with 11 Labs. Their API is a game changer for embedding dynamic, responsive voice interactions in your applications, providing unprecedented realism, flexibility, and latency. In fact, you're listening to one of their voices right now. If you are a developer looking to elevate user experience with natural voice interfaces, this is your solution. Visit upnext.fm/11 to check out their latest offerings. First, Anthropic has extended Claude Fable 5 access on all paid plans through July 19th, according to a post highlighted by Simon Willison. The company is also keeping Claude Code weekly rate limits 50% higher for now, and says users can spend up to half of their weekly limit on Fable 5. The broader signal here is continued demand and continued compute balancing around premium frontier models. Next, Apple says a former employee exploited a rare bug to download confidential files after leaving for OpenAI, according to TechCrunch. Apple would not comment on the security breach itself, but the report says the employee allegedly accessed sensitive files from Apple's network after departure. This is still at the allegation stage, but it adds another layer to the already tense Apple-OpenAI relationship. And finally, Ars Technica has a useful piece on world models, the idea that AI systems may increasingly try to simulate the physical world, or at least a workable approximation of it, instead of only processing language. The takeaway is less that world models have arrived and more that they're drawing real attention, funding, and open questions about what they can actually do. Before we wrap up, a quick note. This podcast is generated with the assistance of AI and is intended for informational purposes only. All referenced articles, research, and commentary remain the property of their original authors and publishers. If you enjoyed this episode, don't forget to subscribe, rate, and leave us a review. And that's your briefing for today. Full source links are in the episode notes, and we'll be back tomorrow with What's Up Next.